Hi, my name is Natalie Covarrubias. I am a student at UTRGV, and today I'm going to be explaining phase shift for graph y equals a sine bx plus c. So let's go ahead and get started. What you have up right now is the graph for y equals a sine bx. So as of right now, we don't have any phase shift. Let me go ahead and show you and explain what the amplitude and the period would be for this particular graph. So like I mentioned, we have y equals a sine bx. So the amplitude in this case would be 1. Since this is the midline right here, the amplitude, as you can see, is 1. It only goes from y0, it goes up to 1, only once. So that would be your amplitude. Now for the period, the way to get your period, it would have to be using the formula 2 pi over b, which in this case would be 2 pi over 1 equal to 2 pi. Let me go ahead and show you. The blue part would be it. So 2 pi b is equal to 2 pi over 1, since in this case the period would be 1. It would be equal to 2 pi. Now I'm going to go ahead and explain phase shift. So now if you get the graph y equals a sine bx plus c, the way to get your phase shift, you would have to equal bx plus c to 0 and work for x. So let me go ahead and show you how you would do that. So as you can see, these are the values for a, b, and c. So for a, b, and c, we're going to be using 1 only. Now let me go ahead and show you. Y equals a sine bx plus c. So we're going to equal bx plus c to 0. And this is the way you would work it. Okay, so it'd be bx plus c equal to 0. You're going to move the positive c to the other side, meaning you're going to equal it to negative c. So bx is equal to negative c. You want the x by itself, so you're going to go ahead and divide by b. And you get x is equal to negative c over b. So since it is negative, you'd be shifting to the left. Now if we substitute b, c for 1, we're going to go ahead and get 1x plus 1 equal to 0. We're going to move the 1 to the other side, so you get x is equal to negative 1, and it means that you're shifting left 1 time. So now let me go ahead and show you the graph for y is equal to a sine bx plus c. Okay. So the lighter green would be the graph for y equals a sine bx plus c. As you can see, this is the original graph, the point that's 0, 0. That is for y equals a sine bx. Now once you have y equals a sine bx plus c, as you can see, it shifts 1 time to the left. So now I'm going to go ahead and show you how you get the graph, the phase shift of y equals a sine bx minus c. So let me go ahead and remove the graph for y equals a sine bx plus c. And we're back at y equals a sine bx. So you're basically going to do the same thing. You're going to go ahead and equal bx minus c to 0. So let me go ahead and show you one last time. So this is the way you would do it. So it's bx minus c equal to 0. You're going to go ahead and move the negative c to the other side, so you get plus c plus c. Bx is equal to c. Now you want to you want to leave x alone, so you're going to go ahead and divide by b, which is this part right here. And you're going to get x is equal to cb. So since it is positive, we would be moving to the right. Now if we substitute b and c for 1, like I mentioned before, you'd get x minus 1 is equal to 0. You move the negative 1 to the other side, getting x is equal to 1. And that is how you see that your phase shift would be would move right 1 time. And so now I'm going to go ahead and show you the graph for y is equal to a sine bx minus c. Okay, so again, we have our original graph, which would be y is equal to a sine bx, right at 0, 0. And since it is this time y equals a sine bx minus c, you see that it shifts one time to the right. And that is how you get your phase shift.